Okay, the purpose of this video is to review solving systems of equations, and we can use various methods. We can use graphing to solve, or we can put the information into the calculators, and the calculators can give us the results. So what I want to do is I want to solve at least the first two problems here by graphing. I'm going to use Desmos, and then I will show you how to solve the same problems using the TI-84. Now, doing this by hand is not going to be very convenient. For example, if you look at problem number 1, I can tell that if x is 0, then I would have negative 5/3 times 0 plus 3. So it would be a line of slope negative 5/3, intercept 3. So I know it would go through this point here. And then I have a slope of negative 5/3. So I would have to go down 1, 2, 3, 4, 5, and over 1, 2, 3. And I'm not sure if I can draw a straight line. Let's see if I can do that between these 2 points. Okay, there we go. So there would be the first line. That would be the first line. And the second line is going to be a line of slope 1/3, intercept negative 3. So I know it's going to go through here. And the slope is 1/3. So I would go up 1 and then over 3. 1, 2, 3. I will say that point would be here. I'll make it a little bigger so we can tell what's going on. And then I'll put the line between those 2 points, and it would be like this. So we can tell that the solution is going to be this point here. Let me try to do that again. We can tell that the solution is going to be this point here, where the 2 lines intersect. Okay. Now, where do those 2 lines intersect? Well, the coordinate for that point is going to be 3, negative 2. Negative 2 is the solution for this system of equations. And a system of equations means that you have more than one equation that you're working with. So that's how we would solve that one by graphing. And that means that if I were to plug 3 in for x here, if I were to substitute in 3 for x and solve, I would get a y value of negative 2. And that would be true for both of these. If I plug in 3 for x, then I would end up getting negative 2 for y. And you can check that on your own. Now let's go to number 2. On number 2, I've got a line of slope 4, intercept 3, so it will pass through here. And it's going to be a line of slope 4. So let's see. That means it would go through here. I know it would hit those 2 points, so let me graph this line. There's the first line. And let's do the second line. The second line is a line of slope negative 1, right? There's a negative 1 here in front of the x, and the intercept is negative 2. So it's going to go through here. And again, it has a slope of negative 1, so I'm going to go back 1, up 1, we'll say. And if we look at the graph that goes through those 2 points, looks something like this. Now, this is the thing I don't like about graphing. If you look at this, it's not very obvious what the solution is because graphing is not always perfect. Even with the computer, sometimes we can be a little off. So let me show you another way we could solve this without graphing. It's a method called substitution. So let's use substitution. This equation here says that y is equal to 4x plus 3. And the second equation says that y is equal to negative x minus 2. Well, if y is equal to 4x plus 3, I'm going to plug in 4x plus 3 here in place of this y. Well, that gives me 4x plus 3 is equal to negative x minus 2. And this method is called substitution. I'm just substituting in one value of y in place of y. Okay. So if y is equal to 4x plus 3, that means that 4x plus 3, which is also known as y, is equal to negative x minus 2. And now I can just solve for x. I'm going to add an x on the right side, which means I would have to add an x on the left side. And if I do that, that's going to leave me with 5x plus 3 is equal to negative x minus 2. I'm sorry, I totally made a mistake there. That would equal negative 2, because the negative x plus x will actually cancel away. I was sitting there thinking ahead about what I wanted to say. I was actually about to say something about the horrible handwriting because I still don't have my digital pen, but anyway. So we have 5x plus 3 is equal to negative 2. And if I subtract 3 from both sides, that means I can have 5x by itself. And if I take negative 2 minus 3, that will leave me with negative 5. And now to get x by itself on the left, I will divide by positive 5, and negative 5 divided by positive 5 is negative 1. So I know the x value is negative 1. That means I can plug negative 1 back up here for x, and that would give me 4 times negative 1, which is negative 4. And then I will have negative 4 plus 3. So that means if x is negative 1, y has to equal negative 1. And that verifies that this point here, where the two lines intersect, should be at the point negative 1, negative 1. So the graph was a little misleading because of human error, but thank goodness mathematics is usually right on the money. So I know the point is negative 1, negative 1. And you can use substitution to solve any of these. In fact, let's look at number 4. That one's fairly easy. If y is equal to negative 1, then that means I can plug in negative 1 for y here. So that's going to leave me negative 1 is equal to negative 5 halves x plus 4. And now what can I do to get x by itself? Well, I could subtract 4 from both sides, and that would leave me negative 1 minus 4 on the left side, which is negative 5. And if I subtract 4 on the right side, that will leave me negative 5 halves x. And now to get rid of the fraction, I'll just multiply both sides by 2. I'll multiply the right side by 2, and I will multiply the left side by 2. So remember, we're multiplying, and negative 5 times positive 2 is negative 10. And on the other side, since I multiplied by 2, these will cancel away, and that will leave me negative 10 is equal to negative 5x. And now I would just divide both sides by negative 5, which means x is equal to positive 2. Luckily, we already know from the problem, let me rewrite this. Luckily, we already know from the problem that y is equal to negative 1. So again, we know that x is equal to positive 2, and we know that y is equal to negative 1. They already gave us that. So that tells me that if I were to graph these two lines, they would intersect at the point where x is 2 and y is equal to -1. Now, to verify that, let's take a look at the graphing calculator. I'm sorry, let's take a look at Desmos first. And we'll graph all of these on Desmos because I really want you all to get used to doing that. First, let me erase this. Okay, so if I go to Desmos and I type these in, let's type in the first one. The first problem was -5/3 x.
Okay, so they transition D lunch back to first block. D lunch back to first block. Thanks.
-5/3 x plus 3. That's the first equation. The second one is 1/3 x minus 3. And make sure you type this in correctly, right? -1/3 x minus 3. And notice that those two lines do intersect at the point 3, -2. And that's what we got when we solved it earlier. So that takes care. And again, this is solving a system by graphing. And when we solve a system, all we're trying to figure out is where do the graphs touch? Where do they meet? Okay, so let's look at the second problem we did, problem number 2. We had 4x plus 3 and -x minus 2. And we can see that the blue line and the green line intersect at -1, -1. That's the second problem that we did. That's the one that was a little hard to interpret, so we ended up solving it by substitution. But we can see here that the answer is -1, -1. And finally, let's take a look at the last one we did. That's the one that said y is equal to -1. And as you can see, that's a horizontal line. And then the second one said y is equal to -x minus 2. I'm sorry, -5/2 x. Plus 4. And we can see that they intersect here when x is 2 and y is -1, and that's what we got when we solved by substitution. So substitution is one way to solve a system of equations, and graphing is another. Now I want to show you one more way that we can solve a system of equations, and this involves using a matrix inside of the TI-84. So let's take a switch here and do that. Okay, so here we go. If you want to do a matrix, first of all, let me write down the problem that we have, and then we'll go from there. Remember, the first problem said y is equal to -5/3 x plus 3. The second one said y is equal to 1/3 x minus 3. So without being too redundant here, I do want to repeat that we've learned how to solve this using substitution, and we have learned how to solve these using graphing. We could use Desmos. I could actually type both of these into Desmos and I would get the solution. Or I could enter these into a matrix on the TI-84. Now, in order to put these into a matrix, we have some rules here. The rules say that anything that has a variable has to be on one side, and any number that's left by itself goes on the other side. In other words, I'm going to have to rewrite this one as positive 5/3 x. In other words, I have to take that negative 5/3 x to the other side. That will make it positive 5/3 x. And notice this is really 1y, so that's going to be plus 1y. I'm not going to write the 1 because we know it's there. And that's going to be equal to positive 3. And for the second equation here, I have to do the same thing. I have to get the x's and y's on the same side. So I'm going to take the positive 1/3 to the other side, and that would give me negative 1/3 x plus y is equal to -3. And now I'm going to put this into a matrix using the TI-84. So to do a matrix, you're going to go to second function, matrix. Let's try that again, second function matrix. And I'm going to go to edit. I'm going to choose number 1, and this is going to be matrix A. And they want to know what are the dimensions of this matrix. Well, if we take a look at the problem we have, I can tell that I have 2 rows. I have row 1 here and row 2 here, and then I'm going to have 3 columns. I have the column for x, I have the column for y, and then I have the column for the constant numbers. So this is actually we have to do row by column, so this is a 2 by 3 matrix. So on the calculator, I'm going to change this to 2 by 3. And I'm going to hit enter. And now I just put those numbers in. I'm going to put the coefficients in. I'm going to put 5/3 in. Next, I'm going to put in 1 because I have a 1 in front of the y. Then I have to put the 3 in. That takes care of the top row. And now for the bottom row, I have to enter -1/3 for the x column. I still have to put the 1 in for the y, and then I'll put in -3 for the constant. Now once you do that, the calculator will do the rest of the work. You're going to go to second function again, select matrix, then you're going to go over and select math, then you will go down to rref, select it, and then you have, okay, let me fix this very quickly. I did not hit enter here, so it did not take that value. All right, so that should be it. Now I'm going to go back out. Now I'm going to hit second matrix, and I should be able to go over to math, go down to rref. Now I will tell it to use matrix, so I'll do second matrix. And remember, we called the first one matrix A, so I'll just select that. Now it's going to do row reduced echelon form on matrix A. And here are my answers. Here's how we read this. This top line here means that x is equal to 3 and y is equal to -2. So x is equal to 3 and y is equal to -2. And earlier when we graphed that on Desmos, that's what we got for the solution, right? We got x is 3 and y is -2. So that tells me that at the point 3, -2, which is in the fourth quadrant, that would be where those two lines intersect. Okay. Okay, let me clear the history here. And let's do another set. This time I'll try to write lower so we're not blocking our view, but let's do problem number 2. Remember problem number 2, we had y is equal to 4x plus 3. And on line 2, I have y is equal to negative x minus 2. Well, remember, if we want to use the TI-84 to solve this using a matrix, we have to write this in proper form. So I'm going to have the x column and the y column on one side, and then I'll have the constant values on the left side. So I'm going to take 4x to the other side, and that would be negative 4x plus y is equal to 3. And then if I take this negative x to the other side, that would give me a positive x plus y is equal to negative 2. And now that I have this written in the proper form, I can go to the TI-84, and let's do this again. I'm going to select second function, matrix, and again, this is another 2 rows, 3 columns, so 2 by 3, it already says 2 by 3, and I'm going to edit the matrix to put my new values in. So I would go over to edit, select enter, and that just means I'm going to change the values that are inside the matrix to the new values. And what are the new values? Well, in front of the x on the top line, I have a negative 4, so that's going to go in the top right. Make sure you hit enter. Then you're going to put the 1 in because you have 1y, select enter, and then that's equal to 3. So put 3 in, select enter. Then you go to the second row. We have 1x, so I'll put 1 in, select enter. Then I have 1y, so I'll select 1, enter, and that's equal to negative 2. So I'll do negative 2, enter. Now, last time I did not do this, and it caused a little confusion. You caught me making a mistake, right? But that's okay. We learn from those. I'm now going to hit second function, quit. That gets me out of there. And I'm going to go back. I'm going to select second function matrix. And again, we're going to do that row reduced echelon form. Go over to the math menu. Go down to rref. Select it. Again, we're using matrix A, so we're going to tell it to rref. Select matrix A, hit enter, and here we go. You'll recall earlier when we graphed and when we used substitution, we figured out that those lines intersected at negative 1, 1. And if you look at this, this tells you that the x value is negative 1, and this row here tells you that the y value is also negative 1. That means these two lines, if you graph these or solve by substitution, or if you use the matrix here, these two lines intersect at negative 1, negative 1. So this is how you would solve a system of equations using a matrix on the TI-84. Let's do one that's a little more complicated. Suppose you have, let's say we have negative 7x minus 2y is equal to negative 13. And x minus 2y is equal to positive 11. Now, luckily, this problem is already in standard form. In other words, I already have the x column here, I have the y column, and I have the constant column. I don't have to rewrite this. So that's one good thing about this. I don't know about you, but I would not want to solve this by trying to graph. I think this would be somewhat challenging to graph correctly, even under the best of circumstances, because it looks to me like we will have some decimals involved. But what we can do is we could use substitution. That would not be too bad, but honestly, my favorite way to solve this is going to be to use the TI-84. And since they're already written in standard form, let's do that. Again, this is another 2 by 3 matrix. So I'm going to go to second function, matrix. It's a 2 by 3. I'm going to edit the matrix. That just means I have new values to put in. And it's a 2 by 3. And the top right number is going to be -7. That's the coefficient on the X. Select enter. Then I'm going to put in -2 for the Y coefficient. And the constant value is -13. Then I go to the second row. I'm going to plug in 1 for X. And -2 for Y. And finally, +11 for the constant value. Hit enter. And then we're going to quit, second quit. Go back again to the matrix menu. This time we're going to go to the math menu, select rref. And again, we're going to tell it to go to matrix A and run this. And when it does, we have the solutions. So the calculator really helps. I can tell from the display that the X value is +3, and I can tell that the Y value is -4. So that means that these two lines here intersect in the fourth quadrant where X is 3 and Y is equal to -4. Now this would not be too bad to graph on Desmos. In fact, I want us to do that. We'll do that on Desmos next. So we're going to switch over. And I'm going to put both of these into Desmos. We had -7x minus 2y is equal to -13. And then the second equation said x minus 2y is equal to 11. And as we can see, the two lines intersect at the point 3, -4. And if I go back to the calculator, we can see that we got 3, -4 there as well. So I hope this lesson actually helped you to figure out how to solve a system of equations. Remember that the reason we want to solve a system of equations is to try to figure out where the graphs intersect, because that gives us a lot of information, especially if you proceed and take higher level math, especially in college. If you take a finance class that has math in it, then you will definitely apply this. But for now, make sure that if we give you a system of equations, make sure that you can solve it by graphing, either on Desmos or on the TI-84. Make sure that you could use substitution if you had to, or make sure that you could actually type these into a matrix and solve using the TI-84. Thank you.